Now we are going to find the angle between two directed line segment in the 3D plane. Suppose that you can see in the figure, suppose that we have two directed line segments L and L1 and L2 like that, and P and Q be any arbitrary points in that line. Let theta be the acute angle formed in between that line. Let A1, A1, B1, C1 be the direction ratios of the line L1, and for the line L2 the direction ratios be A2, B2 and C2. Then of course you can imagine that the position vectors of corresponding points as A1 I cap plus B1 I j cap plus C1 k cap and A2 j cap I cap plus B2 j cap plus C2 k cap and so on. For the sake of convenience, let A1, B1, C1 be the direction ratios of L1 and A2, B2, C2 be the direction ratios of L2. Then the angle between these two lines is equal to cos theta is equal to, we know that A dot B divided by mod A into mod B is the formula to find the angle between two vectors. Considering these two lines as two vectors, two directed line segments, we have cos theta is equal to A dot B, which is A1 A2 plus B1 B2 plus C1 C2. A1 A2 plus B1 B2 plus C1 C2 whole divided by mod A is nothing but square root of A1 square plus B1 square plus C1 square and into A2 square plus mod B, B2 square plus C2 square. Actually we are considering B as the vector L2 and A as the vector L1. So we get cos theta, the angle between these two vectors, as like this. Now we can easily find sin theta. Sin theta is nothing but square root of 1 minus cos square theta, isn't it? We know that cos square theta is nothing but A1 A2 plus B1 B2 plus C1 C2 the whole square, whole divided by A1 square plus B1 square plus C1 square. The square root will be eliminated on taking square into A2 square plus B2 square plus C2 square, isn't it? So on simplifying we will get sin theta is equal to square root of 1 minus, this root should be very bigger, 1 minus, what is this? Cos square theta is nothing but A1 A2 plus B1 B2 plus C1 C2 the whole square divided by what? Square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. So this is the result. Now we can, on taking cos square theta, this square root will be eliminated, right? So this is the result. So we can now simplify this. It is equal to square root of A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square minus A1 A2 plus B1 B2 plus C1 C2 the whole square, right? We are taking LCM divided by A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square, right? We can simplify this further as it is equal to square root of A1 B2 minus A2 B1 the whole square plus B1 C2 minus B2 C1 the whole square plus C1 A2 minus C2 A1 the whole square whole divided by A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square. Don't worry about this conversion. We have just rearranged this entire thing into a form like this in order to ease our calculation. So this is the sin theta and this is cos theta. So if we have to find sin theta and cos theta or even theta, we can use one of the formulas from these two so that we can easily find. See, in both the equation only things involved are a1, a2, b1, b2 and c1, c2, and we are provided with those two things as the direction ratios of the lines L1 and L2. Now we shall check for the properties of these two result. So now we have sin cos theta is equal to this equation. Let me name this was first equation, and sin theta is equal to this equation. Let me name this as second equation. Now if the lines L1 is perpendicular to L2, that is theta is equal to 90 degree, right? So cos 90 degree will be 0. So from equation 1, cos 90 degree is equal to 0. So the left side becomes 0, but the denominator cannot be equal to 0, right? If the denominator equal to 0, then this fraction is not defined. So the denominator cannot be equal to 0. So the only possibility is the numerator equal to 0, which implies that a1 a2 plus b1 b2 plus c1 c2 is equal to 0, isn't it? See. So, in order to check whether two lines with the direction ratios a1, b1, c1 and a2, b2, c2 are perpendicular or not, just check that this product is sum of the product is equal to 0. That is a1, whether a1, a2 plus b1, b2 plus c1, c2 is equal to 0 or not. If it is equal to 0, the lines L1 and L2 is perpendicular, otherwise it is not perpendicular. Now, suppose that L1 is parallel to L2, then theta is equal to 0 degree. Then by the second equation, the left side sin 0 is equal to 0. Likewise, we have denominator cannot be equal to 0. So the only possibility is this quantity is equal to 0. That means square root of a1 b2 minus a2 b1 the whole square plus b1 c2 minus b2 c1 the whole square plus c1 a2 minus c2 a1 the whole square is equal to 0. Now a square root equal to 0 means the square also must be equal to 0. So we can eliminate this square root, which means that a1 b2 minus a2 b1 the whole square plus b1 c2 minus b2 c1 the whole square plus c1 a2 minus c2 a1 the whole square is equal to 0. See, this thing is a non-negative quantity, this thing is a non-negative quantity also, this is also a non-negative quantity, and the sum of three non-negative quantities equal to 0, which means that each of the components of this sum must be equal to 0, which means that a1 b2 minus a2 b1 must be equal to 0, which means that a1 b2 is equal to a2 b1, which implies a1 by a2 is equal to b1 by b2, right? So this is the first condition. Now this component is also is equal to 0, which means that b1 c2 minus b2 c1 is equal to 0, which means that b1 c2 is equal to b2 c1, which implies b1 by b2 is equal to c2 by c1. See, b1 by b2 is equal to a1 by a2, which is again is equal to c2 by c1 by this condition. So we can write a1 by a2 is equal to b1 by b2 is equal to c1 by c2, c1 by c2. So whenever two vectors are parallel or theta is equal to 90 degree, this will happen. So in order to check whether two lines are parallel, just check these ratios a1 by a2, b1 by b2, c1 by c2. If they are equal, then we can say that these two lines are parallel. That's it, the properties of the finding the angle between these two vectors or these two directed line segments. It's an important note from this session. Suppose that if we are provided with direction cosines L1, M1 and N1, L1, M1, N1 and L2, M2 and N2 for line L1 and L2 respectively, then the formula for the angle between them is changes to cos theta is equal to mod L1 L2 plus M1 M2 plus N1 N2, because we know that L1 square plus M1 square plus N1 square is equal to L2 square plus M2 square plus N2 square is nothing but 1. The sum of the squares of direction cosines is always 1. So the denominator will become 1 and what remains is the numerator itself from in the previous equation. Also sin theta will changes too. Just like that, the denominator becomes 1. Square root of 1 into square root of 1 is again 1. So we have this formula. So remember these two formulas also. If we are given with the direction cosines instead of direction ratios, the angle can be evaluated using this formula. So that's the end of the angle between two vector lines. We are considering them as two directed line segments, so it is easy for us to find the angle between those two vectors using the formula we used in the chapter vectors.